Welcome to the Explainer. Today, we're going to pull back the curtain on the invisible rules that basically run your entire digital life.
Have you ever stopped to think about that? It all comes down to these two, completely different ways of thinking about how to send stuff across the internet. It's this constant tug of war between getting it perfect and getting it there right now.
All right, so let's get right into it. We're going to start at the internet's main sorting office, a place called the transport layer.
So you can think of it like this. The regular mail service knows your street address, right? But the transport layer, it knows exactly who in the house that letter is for. It uses these things called ports. They're like unique apartment numbers for your apps to make absolutely sure that your web browser data doesn't accidentally end up in your Zoom call or vice versa. And to actually get this job done, the transport layer uses two main messengers. And they have, let's just say they have very different personalities. You've got TCP, who is the super reliable planner, the one who triple checks everything. And then you have UDP, the speedy courier who's just all about speed, speed, speed.
Okay, first up, let's get to know TCP. This is the protocol that is absolutely obsessed with getting every single detail perfect.
And that phone call analogy, it is spot on. It perfectly describes what we call connection-oriented. See, with TCP, not a single piece of data gets sent until a formal connection is made. Both sides have to agree they're ready to talk. It's all about setting the stage before the show begins.
And here's how that phone call actually starts. It's this formal little dance called the three-way handshake. Your computer sends a message saying, "Hey, you there?" That's the SYN. The server replies, "Yep, I'm here and I hear you." That's the SYN-ACK. Then your computer says, "Great, let's talk." That's the final ACK. Only after that whole polite introduction is over does the real data start flowing.
Now, to make all this reliability happen, TCP has this entire toolkit at its disposal. Look at this. It puts a sequence number on every single byte of data so it can be put back together perfectly. It demands a confirmation, an ACK, for everything it sends. It even acts like a traffic cop with flow control and congestion control to slow things down if the network gets jammed up. It's incredibly thorough.
But all that careful planning and all those tools, they don't come for free. There's a cost. Every single packet of data has to carry all this extra information. It's called a header, and it's at least 20 bytes long. Think of it like a bunch of paperwork attached to every package to guarantee it gets there.
Okay, so that's TCP. Now, let's flip the coin and look at our other messenger, UDP, which, it could not be more different.
The whole philosophy behind UDP is basically the exact opposite of TCP. It's all about speed over everything else. It's what we call connectionless. It doesn't bother with handshakes or setups. It just sends the data. It is the definition of fire and forget.
And honestly, nothing shows you its core principle better than this. Just look at that header. It's a tiny fixed 8 bytes. There is just no space in there for all of TCP's paperwork and rules. It's got the bare minimum, where it's from, where it's going, how long it is, and that's about it.
So this is really the key takeaway for UDP. It gives you basically none of the guarantees that TCP does. There's no promise of delivery. It couldn't care less about the order the packets arrive in, and it's not going to slow down for anyone. All of that responsibility, it just pushes it up to the application to figure out.
So, okay, TCP is reliable, UDP is fast. Seems like a pretty simple choice, doesn't it? But here's where the story gets interesting. It turns out that TCP's greatest strength, that absolute reliability, is also its biggest weakness, especially on the internet we use today.
See, TCP is, it's obsessed. It has this one unbreakable rule. Every single byte must be delivered in the exact right order. So if, say, packet number 2 gets lost somewhere on the way, TCP will get packets 3, 4, and 5, and it will just sit on them. It refuses to hand them over until that missing packet 2 is found and resent.
And that obsession with order, it creates this massive problem called head-of-line blocking. The best way to picture it is a traffic jam. One car breaks down in one lane, and suddenly every single car behind it is stuck, even if the other lanes are totally clear. And for things like video calls or gaming, this is what causes those awful, frustrating lags and stutters. But that exact problem, head-of-line blocking, is what led to the creation of a modern-day hero protocol, one that really tries to give us the best of both worlds. And that hero is QUIC. Now, what's so clever about QUIC is that it's built on top of speedy UDP, but it adds its own layer of smarts. So let's go back to that traffic jam analogy.
With Quick, it's like having multiple lanes. If one packet gets lost, one car breaks down, it only blocks its own lane. All the other data in the other lanes just keeps on flowing. The traffic jam is gone.
Quick is really a massive upgrade for the internet. It sets up connections way faster, it completely gets rid of that head-of-line blocking problem, it can even let you walk out of your house and switch from Wi-Fi to cellular data without your connection even hiccuping. It is the engine that powers the modern web, the thing behind HTTP/3.
Okay, so what does all this mean for you? For the apps and websites you use every single day.
Well, it really all boils down to picking the right tool for the right job. When you're sending an email or loading a website, you absolutely need every single piece of data to show up perfectly. That's a job for TCP. But when you're on a video call or playing a game online, a packet that shows up late is totally useless, so you go with UDP for pure speed. And now, for the modern web, QIC is stepping in to give us the best of both.
And that kind of leaves us with this final big picture thought. The internet was originally built on a foundation of trust, on TCP's promise of absolute perfect reliability. But now, as we chase ever faster speeds and lower delays, we're building our future more and more on UDP's controlled chaos, basically betting on raw speed first and then trying to build reliability on top. And that's a pretty fundamental shift from how this whole thing started.